Okay, I like these problems here because they say, if possible, evaluate. Well, if they're saying that, there's probably a good chance I can evaluate it. So what I want to do is I want to look for a pattern, and I'm hoping this is like what's called telescoping. Now, granted, when I put this down, I'm looking for a pattern, and the pattern on top is always going to be the number 1. That's not an issue for me. Like, I'm always seeing a 1 on top. But on bottom, I want to get this, hope it's going to be something to do with partial fractions. I'm going to be looking around for something, and I'm going to say, 2 times 1, and then I'm going to write down, let's see, I'm going to say 3 times 2. Well, 2 times 1 is 2, and 3 times 2 is 6. And then if that pattern holds, it would be 4 times 3. Well, 4 times 3 is 12. What's the next one going to be? It would be 5 times 4, which is 20. So that seems to be holding up. So what I want to do is I'm going to write down as the sum now. And the sum is going to be written as n starts somewhere. I'll start at 1, and this goes off to infinity. And I'm going to say the terms always look like 1 on top, and then it looks like, it starts at n. That's n is 1, and then n plus 1. And I'm getting it. I see it. All right, now the question is, what do you do now? You got to use partial fractions. So I'm going to write this over here. I'm going to try to split the sum into 2 parts. And that's going to be, let's see, n times n plus 1 is equal to a over n plus b over n plus 1. You get 1 equals a, n plus 1 plus bn. I probably would say n is 0. And if n is 0, you would get a equals 1. Then I would say n equals minus 1. And what would you get? You would get b equals minus 1. So I'm pretty comfortable saying that this sum, starting at 1, off to infinity, well, it's going to be 1 over n minus 1 over n plus 1. By the way, this is my real hope here, that I could write down this over here and figure out what the sum is. And the way we do that is we do it with partial sums. So let me erase this business over here. I'm going to my pre-calculus work. And I want to write down Sn now. And what's Sn going to be? Sn, the stopping number, is going to be that big N. So I write it down, and certainly I'm looking at, I'll put on what I'm looking at. I'm looking at this over here, but I'm not going to infinity. I'm just going up to big N. And the way I like to write it down is I like to, chase one term at a time. So what am I going to get? First term would be 1 over 1. The next term would be 1 over 2. Then 1 over 3. This is plus. And then yada, yada, yada. At the very end, it would be 1 over big N. This is the partial sum. Let me go 1 before it. That's 1 over n minus 1. Let me go 1 before that. It would be 1 over n minus 2. Let's put the next term down, and that's the second one. It's going to be 1 over 2, then minus 1 over 3, then minus 1 over 4. And I go to the end. It's going to be minus 1 over big N plus 1. The term before that is 1 over big N. The one before that is 1 over big N minus 1. There's a lot in between there, isn't there? So what I know about it is it's telescoping. Things are canceling off. This cancels off. This cancels off. Hope you realize there's a term over there would cancel off, and there's a term over there that would cancel off. This cancels. This cancels. So we're kind of left off with something simple. We're left off with this over here. So the Sn, the nth partial sum, is going to be 1, and I'm left with that last guy over there, which is this over here. What do I do now? I take a limit as big N goes to infinity of Sn. And what's that going to be? 1. So what did I do? I just found the infinite sum. What's the infinite sum going to be? It's the number 1. Thank you.